So let's imagine a scenario of a quarterback who throws a pass. So we have the QB throws the ball here, and we're going to assume it takes a parabolic arc to the ground over here. So at some point, P, it reaches a max height H from its starting point A until it lands at B. And because we're assuming that's going to take that parabolic arc, any parabola, our function f of x, has to be defined by three numbers. Lowercase a, which multiplies by x squared, b, which multiplies by x, and the final number, c. So we have three unknowns that define this curve. And there will only be one set of numbers that define that. So because we have three unknowns, we would need three equations in order to solve for those. Well, we have those 3 points. If we introduce an xy coordinate system here, such that, this is our 0, 0 point, well, then we know that f of 0 has to equal a. So now we just know that this is going to be a times 0 squared, b times 0 plus c. So that's very simple. That implies that a equals our c value, or c equals our a value, since we know what a is. So that's probably, let's assume that's the height of the quarterback. So we know the height of the quarterback there. Well, then we also know, based on this, that at our b, the distance that the ball traveled, height's going to be 0. So now we have that a, b squared, plus bb, plus c, but now we know c is a. Okay. So that now leaves our two unknowns, little a, little b. And then the only other part that we don't, let's assume we maybe have values for are this p and h. So f of p at peak distance reaches max height h. Then we know that a times p squared plus b times p plus big A has to all equal h right there. All right, so now really what we have is a system of two equations and our two unknowns, little a, little b. Sweet. Do some rearranging there. We have that b squared times little a plus big B times little b has to equal a negative a. And then we have that p squared times little a plus p times little b has to equal h minus a. And we know, just as a reminder here, that h minus a has to be positive because the quarterback threw an upward trajectory there. So this minus this has to be a positive number. Well, now if we want to get really fancy, what we can do with this is I can actually introduce the matrix form of that. So now, because it's in a matrix form, to solve for little a, little b, I just have to check if this matrix right here, b squared b, big B squared big B, big P squared P has a determinant. And as long as it has a determinant, this system is solvable. And some other fancy matrix operations, things that I can do. I can actually factor out a big B from the top line, a big P from the bottom line, and actually be left with just B1, P1. That didn't really look like a make the very big tail there on the egg. So now the question becomes, if we let's just call this our K matrix. So the question becomes, does K inverse exist? If yes, then that would imply that A, B is equal to 1 over B times P, K inverse, negative A, H minus A. Well, turns out that knowing this question, if it exists, is simply checking whether the determinant, which is the main diagonal, the product of the main diagonal minus the product of the off diagonal, does not equal 0. So as long as the peak height, so K inverse exists, so long as B does not equal P. And going back from our diagram from before, the only way for big B to equal big P is if the max height that the ball was thrown was the ground. Which would also be danger if, let's say, the quarterback threw it. Or no, it would mean that didn't have nothing to do with, sorry, B and P are X values. So it'd have to be that basically the quarterback didn't actually throw the ball. As long as the quarterback threw the ball some distance and it followed our estimated parabolic flight, this whole system of equations now can simply be solved using that formula. So naturally the question becomes, well, if that is K, what is K inverse? So K inverse is exactly the matrix that when multiplied times K gets us back to the identity matrix of 1, 0, 0, 1. And in order to make that happen, there's like a fancy shorthand, I'm just forgetting it at the moment. I think it's, you flip these two and make these negative? No, that is definitely not right. It might be right. Because I think technically you also have to divide by the determinant. It works in that direction. And in that direction, yep. So yes. So yeah, with a 2 by 2 matrix, to find the determinant, you multiply by 1 over the determinant, which we already found previously. The determinant was b minus p. You flip the positions of the main diagonal, and then just make the off diagonal negative. So K inverse is exactly that. So our system of three so our little a, little b, then becomes 1 over b times p from there, times 1 over b minus p, 1, negative p, b, times a negative a, h minus a, and 2 by 2 and 2 by 1, yep, that can be now simplified a little more. So that becomes a negative a minus h plus a minus, oh, actually plus a times p plus b times h minus a. So you can see there that the a's actually cancel out, and so left with just a minus a. Write it nice and big up top here. So now, because of doing that, I have to reintroduce this. Because C was really just A. So if I wanted to be able to pull this out front of the little a, little b, I just have to kind of I have to introduce those factors to our little c term, which little c equals big A. Little a is simply equal to the negative of the max height h. And the most complicated term is AP plus B times H minus A. And there you have it. So that would be the exact coefficients needed to describe a parabolic flight of a football starting from point A, landing on the ground, reaching a max height of h at point P before it lands on the ground at point B. These coefficients would perfectly describe this parabolic flight, assuming it follows the parabola. If you have any other math questions, feel free to drop them in the comments below, or shoot me an email directly to jackalbruitt@gmail.com. If it's going to be a more detailed, in-depth question, I'd be really curious to see what you're struggling with and hopefully be able to lend a hand. But in the meantime, why don't you drop a like on this video, check out some of my other videos, and if it's worth your time, hit that subscribe button. It does a lot to help me out as a growing YouTube channel. I cannot put it into words how much it helps and means to me when I see my subscriber count going up and up and up. And with that, I wish you the best of luck. May the Lord bless you and your digital well-being.